Hello people, what's going on? Today we are going to be precise. We are going to look at some of the SAC questions and we are going to learn exactly how to answer them. Then you can get full marks. That's what we are going to do. These questions are based on topic fuel. Alright, let's have a look. Question 1. It's about bioethanol. Alright, have a look at the questions here. I hope you have time to read the question. I will put the question on the description as well, okay? Alright, bioethanol is derived from renewable resources like corn or sugarcane. They are plant materials, aren't they? It serves as a sustainable alternative to fossil fuel, though its production and utilization it significantly reduces greenhouse gases. So mainly we are focusing on carbon dioxide here. Gas emissions while contributing to clean environment and energy security, while promoting agricultural diversification and rural development. Okay, so that's the introduction. Let's look at the question. Describe the process in bioethanol is produced. Describe. 2 marks. So I'm going to tell you how to get these 2 marks. So first thing is to describe the process. Now what is the name of the process? Let's be clear. You need to write down the name of the process. Fermentation. Let's be more precise. Let's write it's a fermentation, but anaerobic fermentation should be the answer. To say, you get 1 mark for saying anaerobic fermentation. Okay, so 1 mark for anaerobic fermentation. After that, what is the other mark is for? You have to write the balanced chemical equation to show the anaerobic fermentation. Is that clear? So let's write the fermentation reaction. So fermentation happens when glucose. What is glucose? Glucose C6H12O6 states matters, really matter. It matters. So aqueous, all right, and no oxygen, it's anaerobic. So arrow. There's a catalyst. You can write the name of the catalyst on top of the arrow, yeast. Then what are you going to produce? You produce ethanol, C2H5OH, state matters. Ethanol is highly water soluble and carbon dioxide gas. Alright, now this is not balanced obviously. So to balance that, let's put 2 here. I think let's put 2 here. Now that's the balance reaction. So you get 2 marks for writing this, 1 mark, and mentioning the name of the process and anaerobic fermentation. Simples. Alright, let's look at the next question. Write a thermochemical equation for complete thermochemical equation for the complete combustion of bioethanol. Ethanol, same chemical formula. Now in this case it is really important that you put the right state. So thermochemical equation is written under standard condition. So it's the room temperature. So ethanol is a liquid. It's a liquid. Don't write aqueous, you get 0 marks. Plus complete combustion oxygen gas, and you are going to get carbon dioxide gas plus H2O liquid. Now it's a thermochemical equation. Thermochemical equation is a balanced chemical equation with the delta H value on it. So is this equation balanced? No, it's not balanced. So make sure you balance it. Oh, why did I put 2? Okay, I'm trying to balance it for 1 mole of ethanol because I'm going to get the delta H value from the data booklet. In the data booklet, delta H value is given in kilojoules per mole. So in this case, we balance the carbon, then we balance the hydrogen, 6 hydrogen. All right, always balance this oxygen at last, leave that for last because it is by itself, so you can easily manipulate it. So here 7 oxygen, right hand side, 1 oxygen already there, so it's got 3. Now this is a balanced chemical equation. Now missing the delta H value, now you need to make sure you put the delta H value. When it comes to delta H value, it's minus. It's because it's exothermic reaction. So what's the value? Minus 137. Just write kilojoules. You can even write kilojoules per mole. That's totally fine. Both fine. Okay, you can write kilojoules per mole. All right, because we have written it for 1 mole. Yeah, is that clear to you? So that these 2 questions are done and they are pretty straightforward. Let's look at the next one. It's a 3 marker. So how do we get these 3 marks? Let's read the question. Using the responses in part A and part B, explain whether the production and utilization of bioethanol advantageous in reducing the carbon emission. In other words, the question is asking you to say whether bioethanol is carbon neutral or not. Right? That's what the question is asking you. Before we start writing the answer, I'll write a proper answer in the description for your reference. Let's try to get the key idea here. What is the key idea? What is the core idea? Let's try to understand that precisely. Okay. Fossil fuels add new carbon into the environment, whereas the biofuels like bioethanol recycles the carbon. How is that going to happen? Let me explain to you. Plant absorb carbon dioxide during photosynthesis and makes glucose. That glucose becomes bioethanol through fermentation. When that bioethanol is combusted, it releases the carbon dioxide which was previously absorbed, or the same carbon dioxide, same amount of carbon dioxide which was absorbed previously. But this is not perfect. You know that to produce plants, we need to do farming. Farming adds, during farming, it releases carbon dioxide to the atmosphere. To produce bioethanol, you need to transport bioethanol. Transportation might end up releasing carbon dioxide to the atmosphere. So that is why sometimes VCAA gives you questions saying that, or sometimes the teachers give you questions saying that biofuels are not 100% carbon neutral. So to get those 3 marks, you have to say 3 things. What are the 3 things you need to say? You have to say plants absorb carbon dioxide during photosynthesis and makes glucose. Glucose is fermented to make bioethanol. When bioethanol is combusted, it releases carbon dioxide. The carbon dioxide it releases has been previously absorbed. So they release the same amount of carbon dioxide that was previously absorbed. Let me give you that answer in the description. At the same time, you have to say, however, during transportation and farming, there can be extra amount of carbon dioxide released to the environment, so that it is not 100% carbon neutral. However, though, using bioethanol can reduce the amount of carbon that get released into the environment in compared to a fossil fuel. Is that clear? All right. So understand the core idea and look at the answer on the description. All right. All right. Let's look at the next question. Now, to do the next question, you need a lot of stoichiometry. It's a straightforward stoichiometric question. Most people can get marks for a question like this. So let's try to understand let's get the key points. The process is production of bioethanol is on average 70% efficient. All right, the question is asking you have got 2.9 kilograms of glucose was allowed to form bioethanol, and you are given density. Calculate the volume of the bioethanol. So you need to find out the volume of bioethanol obtained from this mass of glucose. So this is based on the previous balanced chemical equation on fermentation. To do these questions, going back to this, if you remember, so if you can find the number of moles of glucose, then you can find the number of moles of ethanol by multiplying it by 2. If you know the number of moles, you can find the grams of ethanol, then you can use the what? You can use the density to find the volume. Now it is important that you include the efficiency into your calculation, because not all the glucose is going to become ethanol. Only 70% of that number of moles of glucose becomes the ethanol. Is that clear? Okay, that's what it says, 70%. All right. So let's try to do this question. Firstly, let's find out the number of moles of glucose. C6H12O6. It is going to be equal to how many grams? 2,900 grams divided by 180.0 as the molar mass of glucose. That will become what? 4 significant figures, 16.11 mole. Just have 16.11 mole. All right, that's the number of moles of glucose. Then if the process is 100% efficient, you are going to get the number of moles of ethanol as what? Number of moles of ethanol as double the amounts, which is, have a look at the ratios. 16.11 times 2 moles. Since the process is 70% efficient, you are not going to get this many moles. You are going to get So with number of moles of ethanol with the efficiency 70% efficiency, that is going to be equal to 16.11 times 2. 70% means 0.7, isn't it? 70%. That's the number of moles of ethanol you are going to get, or you are going to produce. This is going to be what? I think I cannot read. Okay, put those numbers into a calculator. I think you are going to get 22.56 mole. It makes sense, yeah. 22.56 moles of ethanol. Okay, that's the number of moles of ethanol. So then you can find the mass of ethanol. Because to find the volume, you have to use that what formula, density formula. So find the mass of ethanol. Because the question is asking you to find the volume. 22.56 times molar mass of ethanol is 46, I guess. 46, which will give you 1037.56 grams. Double check this number, please. Oh, that's the grams. So how can we use that gram value into liters? But now it's important to know they have given you the density. What does that mean? 1 liter of bioethanol will have 0.89 kilograms. That's what it says there. You see that density? All right, now we got this many grams. We need to find out the volume. So if I'm going to set up the ratio between volume of bioethanol to the mass in kilograms. So I got it in gram. So I want you to convert it into kilogram first. 1.037 kilograms. We got that. Okay. Now I'm going to use this ratio, or you can use density equals mass over volume formula as well, but I like to use the ratio because that will give you a good understanding. 1 liter 0.89 kilograms. How many kilograms have we got here? We got 1.037 kilograms. Then we say x here. I should have written it in this area, sorry. Then 1 over x is going to be equal to 0.89 over 1.037. Then the x is going to be equal to 1.037 okay, did I get it right? Divided by 0.89, which is going to be equal to how many significant figures we need to 2 significant figures. This is going to be equal to somewhere around 20 liters. See whether you can get 20 liters. All right. This is the only calculation part in this question. The rest is writing. Okay, again, this is going to be in the description, okay.